Good morning, everyone. This is Soumyaranjan Nahak, and welcome to my channel Renu Ratna Patsala. Thank you to all for your love and affection and support in my first video. So I am here with my second video, that is how to construct a transition table from a DFA machine. So first of all, we will write what is transition table. Transition table is a table which is used to provide the information about the DFA machine. When we are talking about the DFA machine is the pictorial representation, but transition table is the tabular representation of a DFA machine. So it is a tabular representation. Secondly, it provides the information about the DFA machine. It provides transition table is a tabular representation of DFA machine, and DFA machine is a pictorial representation of DFA machine. So here we got 2 points about the DFA. Next we will learn how to convert or create DFA machine to transition table and transition table to DFA machine. So have a look. So whenever you are facing this kind of question, convert or create a transition table from a DFA machine, first of all you have to focus some basics points, and these basic points are: how many states are there, how many symbols are used by the user. You must have to focus upon it. So first of all, we will write the transition table of this machine. State, how many states are used here? We have to write Q0, Q1, Q2, and the symbol which is used here you must have to write in transition table, that is next state for input 0, next state for input 1. We will make 3 column, one for states and remaining 2 for 2 symbols, because 2 symbols are used here, 0 or 1. So we will write the transition table according to the DFA machine. So first of all we will use arrow mark, because it is not mandatory, but you will use this arrow mark, denotes this is the initial state. Q0 is the initial state. We have 2 inputs as a symbol, that is 0 or 1. If we will use 0 in Q0 states, then to where it will go? If we will use 0 in 1, it will arrive at Q1. So we will write Q1. For input 1, if we will use 1 in input, then we will arrive at Q0 itself. If we will use 0 in Q1, then we will arrive at Q0. For 1, if we will use 1 as a input in Q1 state, then we will arrive at Q2. It's like Q0 and Q1, you have to do the same, you have to follow the same procedure in Q2. In case of Q2, if we will use 0 as a input, then we will arrive at Q2 itself. If we will use 1 in Q2 state, then we will arrive at Q1. So these are the conversion or creation from DFA machine to transition table. Now we will understand or we will learn how to create transition table to DFA machine. So we will write DFA machine, a transition table, that is Q0, Q1, Q2. Then after we will write next state, that is input for 0, input for 1. State Q0, Q1, Q2. We got to know how to convert or create DFA machine to transition table. But now we will understand how to convert transition table to DFA machine. So we will simply write the procedure Q1, Q0, Q2, Q0, Q2, Q1. Then how we will make a DFA machine from the transition table? So have a look. So first of all, we will write the initial state, that is Q0. If we will put 0 as a input in Q0, it will arrive at Q1. Q1 0. Because we got to know if we will use 0 in Q0 states, then we will arrive at Q1. We will simply write here. Then after we will move forward the input 1. If we will use 1 as a input in Q0 state, then we will arrive at Q0 itself. Then we will move toward the Q1. If we will use 0 in Q1 state, then we will go to the or arrived at Q0. If we will use 1 as a input in Q1, then we will arrive at Q2. If we will use 0 in Q2 state, then we will arrive at Q2 itself. If we will use was as a input in Q2 state, then we will arrive at Q1. So here we understood how to create a transition table from DFA machine, and it's vice versa, means transition table to DFA machine and DFA machine to transition table. Whenever you will write or create a DFA machine to transition table, then last state you have to mention or marked by double circle, that is, and here you will see the same thing. From DFA machine to transition table, no states, no symbol have been changed in this procedure. So this is the pictorial representation. This is the tabular representation. Both are defining the characteristics of finite automata because DFA belongs to the finite automata. So first method define how to create transition table from DFA machine, and second method define how to create DFA machine from transition table. So thank you. Have a great day.